The summary for the trig sub. So first of all, you look at the pattern, whether you have like x squared plus a squared, or x squared minus a squared, or a squared minus x squared in the problem. Okay, so for this case, so gonna be x as the opposite, a as the adjacent. The next case, x gonna be the hypotenuse because you have subtraction. X hypotenuse, a adjacent, and the last case, a gonna be the hypotenuse, and then x is the opposite. Whatever you have, you're gonna find the relationship of x over a as a trig sub. Oh, the trig function. Okay, trig function, and then you're gonna solve for x. So next, you're gonna solve for x and write x in terms of a, and the trig function, and then find the differential x, gonna be some term multiplied by d theta. Okay, after you get this, you have the complete right triangle, and then you're gonna substitute x and dx into the integrand. And then you're gonna see the integration in terms of an angle theta and d theta. Okay, terms of theta and d theta. Simplify completely. Okay, and then the next step, what you can do is find the antiderivative or evaluate. And then you may use the complete right triangle. Okay, and then substitute the theta by expression in x to finish off the problem. The number of the steps could be different from one book to another book. So the overall picture gonna be the same, okay, for the trig sub. It's just based on 3 different forms that you begin with and what the appropriate right triangle that you're gonna form. Okay, so this part gonna be the Pythagorean theorem part. The a squared plus b squared equals c squared. So to complete the missing part here, the missing side, using the Pythagorean theorem. And then the trig identity will come depends on, will be used depends on you are using the sine function, the secant function, or the tangent function. Okay, so those 3 will tell you what appropriate trig identity you're gonna use as part of the substitution process.